Hello students, this is the third lecture of the series. In this lecture, we are going to discuss moments. So, what are moments or what is the moment of a random variable? So, the rth moment of a variable x about any point x equal to capital A, say about any point x equal to capital A, say usually denoted by mu, usually denoted by mu r, or usually denoted by mu r dash, rather say usually denoted by mu r dash, is given by mu r dash is equal to 1 by n summation over I fi into xi minus a whole to the power r, fi into xi minus a whole to the power r, where summation fi over I is equal to capital N, as already discussed in the previous videos. Or we can write this as 1 by n summation over I fi into di to the power r, where we have substituted di to be xi minus a. We have substituted di to be xi minus a. Now, if in place of a we put x bar, that is the mean. That means if we now put a equal to x bar, what is x bar? X bar is the mean of the variables, that is 1 by n summation over I fi xi. Then the moments will now denote it by, then the moments will be denoted by mu r and is given by mu r is equal to 1 by n summation over I fi into xi minus x bar to the power r. So you have replaced a by x bar. So you replaced a by x bar, or we can write this as 1 by n summation over I fi into fi into z to the power zi to the power r, where we have substituted zi to be xi minus x bar, So you can now see that if in particular if we put r equal to 0, then this implies mu 0 is equal to 1 by n summation over I fi into xi minus x bar to the power 0, that is equals to 1 by n summation over I fi, that is equals to 1 by n into summation fi is nothing but capital N. This cancels and this gives us 1. So mu 0 is nothing but 1. Similarly, if we put r equal to 1, then mu1 will be equal to 1 by n summation over I fi into xi minus x bar to the power 1. So this is nothing but 1 by n. If we separate the summation, this will be summation over I fi xi minus 1 by n summation over I fi into x bar. This is, we know that this is the definition of mean, the arithmetic mean, that is, this is nothing but x bar. So in this place we can write x bar minus, since in the next term x bar is independent of summation, we can bring x bar out of this. So we have 1 by n into summation over I fi. So this fi and this cancels. Why? Since summation fi is nothing but capital N. So you got x bar minus x bar, that is equal to 0. So you can say that mu1, or the first moment about mean, is 0. The first moment about mean is 0. So proceeding similarly, if we put r equal to 2, then you can see that mu2 is 1 by n summation over I fi into xi minus x bar to the power 2, which is nothing but the variance, which is nothing but the definition of variance, that is sigma square. So mu2 is similarly sigma square. Okay. Now this one, see. So we got some results. So what results we got? So let us collect the results. So we got that mu0 is equal to 1, mu1 is equal to 0, and mu2 is equal to sigma square. Mu2 is equal to sigma square. So these are the fundamental, means what to say, means that these are a fundamental importance. We have to remember this. These are standard results which we can use during problems. Now we also know that while doing means, you have also done this one, that we know that if di is equal to xi minus a, if di is equal to xi minus a, then this implies x bar is equal to a plus 1 by n, a plus 1 by n summation over I fi di, summation over I fi di, that is nothing but a plus, now see this quantity, this is nothing but this mu r dash, the definition of mu r dash. So we can replace this term by mu r dash. So this is nothing but a plus mu, sorry, in place of r now we have 1 here, so we can write this as mu 1 dash. Now therefore we got a result that x bar can be written as a plus mu 1 dash. We shall use this result in the next part, where we will try to find the relation between the moments about mean in terms of moments about any point, or vice versa. So let us next find this one. So what we have is, in the next portion, what we are going to show is relation between moments about mean in terms of moments about any point, in terms of moments about any point. So what we have just discussed, we have that mu r, what is mu r? 1 by capital N summation over I fi into xi minus x bar whole to the power r. That is equal to 1 by n summation over I fi into xi minus, let us adjust a minus a plus a minus x bar whole to the power r. So we have taken an a extra minus a, and to balance that minus a we have taken another plus a, where a is any constant. So we can write this as 1 by n summation over I fi into, this is di plus a minus x bar whole to the power r. And what is di? As we have mentioned before, di is xi minus a, where di is xi minus a. Now what we have also done is that mu r is equal to 1 by n summation over I fi into di plus a minus. Now we have just used a result here, that we have seen a result here that x bar is equal to a plus mu1 dash. So in place of x bar we can write a plus mu1 dash. So we are replacing x bar by a minus mu1 dash whole to the power r, a minus mu1 dash whole to the power r. So this a and this a cancels, so we got this is equal to 1 by n summation over I fi into di minus mu1 dash whole to the power r, di into dy minus mu1 dash whole to the power r. Now let us consider this term di minus mu1 dash whole to the power r and expand this in terms of binomial. Theorem. So what we'll have, so therefore we can write that mu r is equal to 1 by n, summation over I fi into, this is di to the power r minus rc1 di to the power r minus 1 mu1 dash plus rc2 di to the power r minus 2 mu1 dash square minus, continuing in this way, last term will be plus minus 1 whole to the power r mu1 dash whole to the power r, So we have just expanded this mu di minus mu1 dash whole to the power r in terms of binomial. Now let us separate the summation. So this will be what? This will be 1 by n summation over I fi into di to the power r minus rc1 into 1 by n summation over I fi into di to the power r minus 1 into mu1 dash into mu1 dash. Actually, we can do one thing. Since mu1 dash is independent of summation, we can write that mu1 dash out of the summation. So let us write in this way on. This is rc1 into mu1 dash into summation over I. Sorry, 1 by n is there. 1 by n summation over I fi into di to the power r minus 1 plus rc2 mu 1 dash square 1 by n summation over I fi into di to the power r minus 2 minus, continuing in this way we have this sum. Continuing in this way we have this sum, and the last term will be plus minus 1 whole to the power r mu 1 dash r, and this 1 by n into summation fi will come, which will cancel, will give us 1, which will cancel and will give us 1. So now let us see this result that we have written here in the previous page. So this one, say this result, this mu r dash. So what is mu r dash? Mu r dash is 1 by n summation over I fi into di to the power r. Mu r dash equals to 1 by n summation over I fi into di to the power r. So we can write this summation in terms of mu r dash. So in terms of mu r dash. So if we now replace these summations, in terms of mu r dash. This is nothing but mu r dash. This will be what? This will be mu r minus 1 dash. So taking this n together. So this will be mu r1 mu r minus 1 dash. So we will now next substitute these values. So substituting these values, we will get, therefore what we have, that mu r is equal to, this is mu r dash minus rc1 mu r minus 1 dash mu 1 dash plus rc2 mu r minus 2 dash mu 1 dash square minus, continuing in this way, the last term is minus 1 whole to the power r mu 1 dash to the power r, mu 1 dash to the power r. And this is the relation between moment about mean in terms of moment about any point A. Moment about mean in terms of moment about, relation between moments about mean in terms of moments about any point A. Moment about any point A. So in particular, if you go on putting these values, if you go on putting r equals to 2, 3, 4, let us give it a number, say 1. In particular, if we put r equals to 2, 3 and 4, 2, 3 and 4, we get what? Mu 2 will be equal to mu 2 dash minus 2c1 mu 2 minus 1 is mu 1 dash into mu 1 dash and 2c2 plus 2c2 is mu 0 dash into mu 1 dash square. Now what is mu 0 dash? You can see from this one. What is mu 0 dash? So mu 0 will be equals to 1, mu 0. So if you put r equal to 0, you will have 1 by n summation fi, that is equals to 1. 1 by n summation fi will give us 1. So this is nothing but 1 and what is 2c2? 2c2 is again 1. So this is equal to mu2 equals to mu2 dash minus 2 mu1 dash square plus 2c2 is 1 plus mu1 dash square. So this implies mu2 is equal to mu2 dash minus mu1 dash square. This is the result between the moments when r is equal to 2. Similarly, if you put r equals to 3, so in that case m3 is equal to mu3 dash minus 3c1 mu2 dash mu1 dash plus 3c2 mu1 dash mu1 dash square minus 3c3 mu0 dash mu1 dash cube. So on simplifying, we'll get this is equal to mu3 dash minus 3 mu2 dash mu1 dash plus 2 mu1 dash cube. This is the value in terms of mu3 in terms of mu3 dash. So similarly, putting r equals to 4, 5, 6 and going proceeding forward, we will get the relations between this moment and moment about mean in terms of moment about any point. In terms of moment about any point. So okay, next in this one. So let us see the effect. Let us see the effect of change of origin and scale on moments. That is what? Let us put u equal to x minus a by h. A and h are constants, where a and h are constants. So therefore what we have, we can write that x is equal to a plus h into u, and which gives us x bar is equal to a plus h into u bar. For this one you can refer to the first video where we have done step deviation and we have proved this result. So this is, we got that x bar is equal to a plus h into u bar, and therefore what will be x minus x bar? X minus x bar, put the values of x and x bar. So x is a plus hu minus x bar is a plus hu bar, and that gives us h into u minus u bar. So x minus x bar is nothing but h into u minus u bar. So therefore mu r dash is equal to 1 by n summation over I fi into xi minus a whole to the power r is equal to, will be what? 1 by n summation over I fi into, now xi minus a, now this is xi minus a is equal to, will be what? Xi minus a will be now h into uy, h into uy. So h into uy to the power r, this is nothing but h to the power r into 1 by n summation over I fi uy to the power r, fi uy to the power r. So this is the relation between, means this is how x changes. So this is how this a and h effects on u. That means we can say that this h will be multiplied. If you find this mu r dash, then this h to the power r will be multiplied for this u. H to the power r will be multiplied with 1 by n summation over I fi into ui to the power r. Also, if you want to find mu r Also, if you want to find mu1, now mu1 is 1 by n summation over I fi into xi minus x bar to the power r, fi into x minus x bar to the power r. So therefore this is equal to 1 by n summation over I fi into x minus x bar is nothing but h into u minus u bar to the power r, that is equal to again h to the power r into 1 by n summation over I fi into u minus u bar to the power r, which is nothing but h to the power r, which is nothing but this is the moment of this variable u, moment of this variable u. So this is mu r of u, mu r of u. Thus the rth moment of the variable x about mean is h to the power r times the rth moment about the variable u about mean. No. So therefore the rth moment of the variable x is about h to the power r times the rth moment about the variable, sorry, the rth moment of the variable u about. So these are the results for moments. So this is all in this video.